Hi. In the last lesson, we started to look at the Great Glen Fault, and you are answering the questions on page 10 of your booklets. What I want to do today is I want to go through some of the answers to that task, and then to think about the next stage in looking at geological structures, where we start thinking about rocks that are folded. Anyway, let's think about the Great Glen Fault. The first question asks why, or what is it about the Great Glen that suggests it's a fault? We can see from the geology map that there's a change in the geology. The geology to the north and west of that fault is different from the geology to the south and the east. Also, the fact that we have a valley, clearly there's a weakness, and the fact that that is a very straight line. The final piece of evidence we get from these other maps. We can see that there are structures that have been displaced. We see the same pluton of granite that's been moved and displaced by the fault. The next question then asks you to put movement arrows on this map, and we can see this is the movement that we see, and we can tell that from that granite that has been moved by this fault, maybe as much as 70 kilometers. And finally, the movement of that granite also shows us that the Great Glen is a strike slip fault. Now, this is the photograph that you have in your booklet. This photograph is looking towards the northeast along the Great Glen Fault. Okay, actually along looking at Loch Ness. With this then, we can see we've got this very long straight valley, indicative of this being a fault. And now see which side the left side has moved. Now the left side has moved towards us, which makes this a left lateral or sinistral strike slip fault. The last part of this question then asks you to complete these diagrams that have been a little bit, well, poorly photocopied, to be honest. If we complete diagram A, we see a structure like that. We can see there the hanging wall of that fault has been downthrown, so it's a normal fault. If we complete diagram B, we can see the hanging wall of the fault there is upthrown. It's the footwall that's been downthrown, so that's reverse. And finally, if we complete diagram C, we've got horizontal displacement there. It's strike slip. It could, though, be a normal fault as well. It's quite hard to tell with C. Anyway, those are the answers. Let's move it on. Because I want us to talk about folds. We're working here on page 11. And I want us to start talking about a feature in the rocks that we call dip. Now, dip to a geologist is the steepest angle of inclination of usually a bed, but it could be a fault, it could be other features as well, but in particular a bed or a fault. And it's measured relative to horizontal. So the angle of dip is the angle measured from horizontal in degrees. With that, we also talk about the direction that these beds are tilted in. Okay? And we always talk about this in terms of dip going down. So it's the direction and the angle that the beds go down. Now, let me show you what I mean. This is a photograph of an outcrop of rock. This particular photograph was taken looking north. So we've got west on the left, east on the right. And we can see that these beds are not horizontal. They've been tilted. We assume beds are formed horizontally. It's a reasonable assumption to make. So if they're not horizontal, tectonics has moved them. So if I want to measure the dip of these beds, we look for the horizontal and the angle that those beds make with horizontal. So the angle I've indicated there is the angle of dip. In this case, it's about 30 degrees. So we've got a dip of 30 degrees to the west, because that's the way that angle or those beds are going down. Okay. What I'd like you to do now on page 11 is, using a protractor, I'd like you to measure the angle of dip of each of these, that's shown in each of these photographs. So draw a horizontal line onto each of them, and then measure the angle down from that horizontal line for each of those. Also, using the information that's in your booklet, what direction is that going? Remember, what direction is it going down? So, press pause now and have a go at that. Okay then, let's see what you've come up with. So these are our 3 outcrops of rock that we need to measure the dip from. Let's start on the left. The dip here is to the north, because that's the way the bed's going down. If we measure the angle, we should get about 35 degrees or so. In the middle, we can see the dip is gentler and in a different direction. So we've got a dip, in this case, going to the northeast, and the dip angle here is maybe 7 to 15 degrees, depending exactly how you've measured it, but somewhere around that sort of ballpark. And finally, on the right, we can see we've got much steeper beds. Here, the beds are dipping to the east-southeast, and the angle of dip is between 70 and 75 degrees. They're much, much steeper. Vertical beds, of course, would be 90 degrees. Horizontal beds would be 0. Okay then. So once we've got the idea of dip, we then need to start putting that into understanding what we mean by a fold. Now, a fold is a bend in the rock. It's where we have ductile deformation going on. Now, what I'd like to do is I'd like to go through each of these features that are labelled in your booklets at the bottom of page 11 and explain what these features actually show. So like we did with the faults, I'd like you to add some annotation to the labels for each of these features of a fold. And we're going to start with a hinge. A hinge is really the point that the rest of the fold is defined around. So a hinge is the point on a bed where that bed is bent, where the dip changes. So the hinge is the point where the dip changes. If we join together all the hinge points on one bed, that makes the axis. So the axis is a line that joins together all the hinge points on one bed. If we join together all the hinge points on several beds. So we're joining up the axes for each bed that we can see. That makes this imaginary surface we call an axial plane. Okay. We then have a couple more terms. We have the limb of a fold, and the limb is the dipping bed in between hinges. A limb won't just be a limb for one fold, it'll be a limb for maybe two folds. So the limb that's in the middle of this particular diagram, it's not labelled, but the one that's in the middle, that's a limb for both the folds we can see here. Okay. There are two types of folds then we need to be familiar with. Firstly, we have an antiform. An antiform is an upfold, where beds have been pushed up, and the limbs then dip away from the axis. In a synform, which is a downfold, the two limbs dip towards the axis. Make sure we've got definitions of each of those terms. It's important that we understand the bits of these folds if we're going to interpret them. Okay. As we see the sunset on Loch Ness again, there are different features of folds, much in the same way that there are different features of faults. If we're going to interpret them, we need to be familiar with those terms. But to interpret these, we need to develop our understanding a little bit more. But that's for another lesson. I'll see you then.